For a moment, forget everything you think you know about Jupiter, because the James Webb Space Telescope has just shown us a version of this planet so strange, so unnerving, and so alive, it barely feels real. In the darkness of space, JWST's infrared eyes cut through Jupiter's clouds like a scalpel, and what it revealed wasn't the familiar striped marble we've seen for decades, but a ghostly giant glowing from within, its storms pulsing like beating hearts, its poles crowned with electric halos so bright they look like portals tearing open the sky. The great red spot, usually calm from afar, burns in Webb's images like a living ember, its heat swirling in deep, invisible spirals. Aurora rings flicker at the edges of the planet, not gently like Earth's, but violently blazing with energy strong enough to power our entire world millions of times over. Jet streams twist in directions no telescope has ever recorded, moving as if they're responding to something hiding beneath the clouds. And then there are the storms. Enormous tempests that shouldn't exist, lightning bursts larger than continents, dark pockets that appear and vanish with no known cause. In Webb's view, Jupiter isn't just a planet, it's a churning, restless colossus, full of motion and mystery, as if the entire atmosphere is alive and aware of our gaze. Scientists expected beauty, they expected clarity, they did not expect this. Because hidden inside these images are secrets that rewrite what we thought Jupiter was, and clues that hint at something far more complex happening deep within the planet's heart. So the question is, what exactly did the James Webb Telescope see inside the solar system's largest world? And why are researchers calling these images shocking? Let's begin. Before we explore what the James Webb Space Telescope uncovered on Jupiter, it's important to understand the machine behind these extraordinary images, because JWST wasn't originally designed with planets like Jupiter in mind, and yet it's revealing details no spacecraft or telescope has ever captured. Launched in December 2021, the James Webb Space Telescope is the world's most advanced space observatory, positioned nearly 1 million miles from Earth at a quiet gravitational point called L2. Its mission is simple in concept, but massive in ambition: to study the universe in infrared light wavelengths our eyes can't see, but which hold the fingerprints of heat, chemistry, structure, and motion across the cosmos. For distant galaxies and early stars, infrared is essential. But for a world like Jupiter, it's transformative. Unlike visible light telescopes, JWST's infrared vision can pierce through Jupiter's thick clouds and reveal the heat escaping from deep within. Jupiter is constantly releasing energy from its interior, and infrared light acts like a window into that hidden world, exposing layers, storms, and atmospheric patterns invisible to traditional imaging. While Hubble shows us Jupiter's surface clouds in beautiful detail, JWST shows us the engines driving those clouds. Then there's NASA's Juno spacecraft, currently orbiting Jupiter. Juno gives us extraordinary close-up data gravity measurements, magnetic mapping, and cloud-level observations, but it studies specific regions at a time as it sweeps past the planet on each orbit. JWST, however, can observe the entire disk of Jupiter at once, from pole to pole, capturing global behavior in a single snapshot. Combined, Juno provides the inside story, while JWST delivers the big picture. And Webb's sensitivity is unmatched. Its instruments can detect faint thermal emissions, subtle chemical signatures, and lightning flashes on Jupiter's night side that no telescope has ever captured from this distance. This combination, high resolution, powerful infrared vision, global perspective, is why the images you're about to see are so shocking. They reveal a Jupiter we have never witnessed before, a giant behaving in ways we didn't expect, glowing with hidden storms, unseen winds, and deep atmospheric mysteries finally coming to light. You're about to see Jupiter like never before. Why Jupiter matters more than we thought. Jupiter isn't just another planet in our solar system. In many ways, it's the reason Earth is still here. Astronomers often call Jupiter the gatekeeper of the solar system because its enormous gravity, more than twice that of all the other planets combined, acts like a cosmic shield. Over billions of years, Jupiter has diverted or absorbed countless comets and asteroids that might otherwise have struck Earth. Some estimates suggest that without a giant planet in Jupiter's position, impacts on our planet could have been far more frequent, possibly preventing life from ever developing the way it has. But Jupiter does more than protect us. It also shapes the architecture of the entire solar system. Its gravity influenced the formation of the asteroid belt, affected the paths of early planets, and even helped determine where Earth eventually settled in its stable, life-friendly orbit. This is why scientists are obsessed with Jupiter. Understanding it isn't just about studying a distant world, it's about understanding why our own world exists in the first place. Its atmosphere, storms, and colossal magnetic field hold clues to how giant planets behave, both here and around other stars. Jupiter's magnetic field is the strongest of any planet in the solar system, generating intense radiation belts and driving auroras far more powerful than Earth's. Its storms, including the Great Red Spot, reveal how energy moves through planetary atmospheres on a massive scale. The better we understand Jupiter's dynamics, its winds, heat, chemistry, and internal structure, the better we understand not only our solar system's history, but the forces that made Earth a safe haven for life. Studying Jupiter isn't just about looking outward, it's about looking back at how we survived and how we continue to survive today. First image reveal. When the James Webb Space Telescope released its first full infrared portrait of Jupiter, the reaction was immediate. This didn't look like the familiar orange-striped gas giant we've known for decades. Instead, the planet appeared almost ghost-white, its clouds glowing in soft, eerie tones as if Jupiter were lit from within. Infrared light reveals heat rather than color, so structures that are warm like high-altitude haze and energetic storms shine brightly. Cooler regions fade into deeper shadows. This transformation strips Jupiter of its usual palette and exposes an underlying anatomy we rarely see. Across the planet, the iconic cloud bands still dominate, but in infrared they become sharper and more textured. The lighter zones glow intensely, showing where sunlight and internal heat scatter off high-altitude aerosols. The darker belts, cooler and denser, sink into shadow, revealing their depth and complexity. Instead of looking painted, the planet suddenly appears layered and three-dimensional. The Great Red Spot, which appears white in infrared, stands out as a massive, bright oval evidence of its high altitude and the energy being released from its towering clouds. Smaller storms, usually lost in visible light images, pop out clearly as glowing eddies and swirling ovals across the surface. And there are surprises you might not expect. Jupiter's thin, faint rings, barely detectable in visible light, stretch across the image as a delicate halo, lit by the infrared glow of dust particles warmed by the sun. Several of Jupiter's moons, including Europa and Thebe, appear as bright points nearby, their icy or rocky surfaces reflecting infrared light in ways never captured with such clarity from this distance. At first glance, the image feels calm, soft, smooth, almost serene. But look closer and the calm dissolves. Every bright feature marks a storm, every glowing filament traces a jet stream, every shadow hints at motion unfolding on a colossal scale. JWST didn't just photograph Jupiter, it peeled back the outer layer and revealed the living machinery underneath. The Great Red Spot in infrared. For more than 350 years, the Great Red Spot has loomed over Jupiter, a storm so massive it once could have swallowed 3 Earths. It is the longest-lasting storm known in the solar system, a swirling anticyclone with winds reaching hundreds of kilometers per hour. And yet, despite centuries of observation, it continues to defy expectations. Visible light telescopes show its color and shape, but JWST's infrared vision reveals something far more revealing: the heat and altitude structure of the storm. In infrared, the Great Red Spot doesn't appear red at all. It glows a stark, bright white, meaning its clouds tower higher than the surrounding atmosphere, catching sunlight and radiating strongly at infrared wavelengths. This elevated structure helps confirm why the storm has persisted for so long. It sits like a massive mountain of clouds, isolated from lower, energy-draining layers. But Webb uncovered deeper subtleties too. The regions around the spot show complex thermal patterns, hotter zones near its periphery, and cooler pockets within, suggesting that the storm's internal energy distribution is far from uniform. These temperature contrasts help drive its powerful winds and maintain its rotation. And here's the mystery: the Great Red Spot is shrinking. Over the last century, it has steadily contracted, now roughly half the size it once was. Yet measurements indicate that while the storm is getting smaller, some of its winds are actually intensifying. In other words, it's becoming more compact, but no weaker. Why this is happening remains one of Jupiter's great puzzles. Some theories point to changes in surrounding jet streams, others suggest shifts in deeper atmospheric layers, but no single explanation fully accounts for the ongoing evolution. What JWST provides is a new layer of insight, detailed thermal structure that gives scientists fresh clues about how energy moves inside the storm. A storm this old shouldn't still be this powerful. And yet, in infrared, it looks more alive than ever. Lightning on the night side. When JWST turned its infrared gaze toward Jupiter's night side, astronomers witnessed something extraordinary: brief, piercing flashes erupting from within the planet's deep atmosphere. These were lightning storms, captured in wavelengths never seen with this level of clarity from space. On Earth, lightning forms in water clouds, but on Jupiter, it forms in towering storm systems that extend far deeper. Data from previous missions, including Juno, had already shown that Jupiter's lightning originates in clouds containing water and ammonia-water mixtures, conditions found much farther below the visible cloud tops than scientists once believed. JWST's infrared sensitivity confirmed this by revealing faint, localized heat signatures where lightning was active, even on the unlit side of the planet. The scale is staggering. Some of these flashes are powerful enough to be detected from nearly 1 billion kilometers away. A single Jovian lightning bolt can illuminate vast regions of the atmosphere, and the storms producing them can span thousands of kilometers, large enough to dwarf entire continents on Earth. In JWST's images, these lightning events appear as small but unmistakably bright points against the darkened hemisphere. They flicker like distant explosions, brief yet intense, hinting at immense convective forces churning deep below. Each flash marks a rising column of moisture and energy, driven upward by internal heat escaping from Jupiter's core. There's something almost unsettling about seeing lightning on a world this massive. On Jupiter, storms don't just erupt, they dominate. They rise through layers of gas thicker than Earth's entire atmosphere, unleash energy on an enormous scale, and vanish back into darkness just as quickly. Captured in infrared, these bolts feel both alien and alive, silent eruptions inside a world built from storms. The polar regions. When JWST photographed Jupiter's polar areas in infrared, the images shone with a brightness unprecedented on Earth. The auroras, typically weak in visible light, blazed like radiant crowns encircling the poles, showcasing formations molded by forces significantly more potent and tumultuous than those affecting our planet's northern and southern lights. Auroras on Earth occur when solar-charged particles engage with our atmosphere and magnetic field. However, the auroras on Jupiter act in a distinct manner. Their movement is not solely influenced by the solar wind. Observations from JWST confirm findings from missions like Juno. Jupiter's auroras are primarily driven by its rotation and by volcanic material from its moon, Io. When Io erupts, it expels gas that gets ionized and captured within Jupiter's extensive magnetosphere. These particles are subsequently propelled along magnetic field lines towards the poles, producing auroras that glow consistently, even on the night side, regardless of the solar wind being calm. JWST's infrared instruments unveiled the heat released by these auroral areas, charting hotspots where particle storms collide with Jupiter's upper atmosphere. These areas exhibit intricate patterns that suggest turbulence in Jupiter's magnetic field, which is among the strongest and most active in the solar system. In contrast to Earth's soft bands of color, Jupiter's auroras are unyielding. Fueled by rotation, magnetism, and volcanic rage, they blaze like celestial engines at the giant's poles. The rings of Jupiter. Most people never realize Jupiter has rings at all. Unlike the bright, icy rings of Saturn, Jupiter's are faint, so faint in fact that they weren't discovered until 1979 by the Voyager 1 spacecraft. They're made not of glittering ice, but of dust, tiny, dark particles constantly shed from Jupiter's small inner moons as micrometeorites strike their surfaces. Because this dust doesn't reflect much visible light, the rings are nearly impossible to see from Earth-based telescopes. But JWST changed that. With its remarkable infrared sensitivity, Webb captured Jupiter's rings glowing with a clarity we've never had before. Instead of appearing invisible or washed out, the rings form a thin, delicate halo encircling the giant planet, subtle yet unmistakable. In JWST's images, the dust warms slightly under sunlight and emits faint infrared radiation, allowing the telescope to detect their structure with precision. These aren't wide, majestic bands like Saturn's. They're narrow, almost ethereal, stretching out from Jupiter in thin arcs. The main ring is only a few thousand kilometers wide, minuscule compared to Jupiter's massive diameter. Even so, JWST recorded their symmetry, their smoothness, and their surprising stillness. That stillness is deceptive. Jupiter's rings are constantly replenished as dust is knocked off its moons. At the same time, the planet's gravity slowly pulls the particles inward, meaning the rings are always in a state of quiet renewal. Webb's infrared images capture this delicate balance, showing a structure that is both fragile and dynamic. Seeing these rings around Jupiter feels almost eerie, like discovering a hidden outline around a world we thought we knew. They're faint, ghost-like reminders that even the most familiar planets hold secrets waiting for the right eyes to uncover. Thanks to JWST, Jupiter's invisible halo is invisible no more. The moons. Jupiter's moons exhibit a remarkable diversity and drama akin to the planet itself, with JWST's infrared capabilities illuminating them in visually stunning and scientifically enlightening ways. Among these, Europa is particularly notable. Its frozen exterior emits a faint glow in infrared, emphasizing areas of broken ice and potential activity beneath the surface. These thermal signatures indicate that the ocean under Europa's ice may be engaging with the surface, potentially forming vents or fissures that permit warmer substance to ascend. This is precisely the type of proof researchers seek when looking for settings that might support life. Io, the volcanic powerhouse of Jupiter, is yet another revelation. Its volcanoes, renowned from the Voyager and Galileo missions, now appear in infrared with unmatched clarity. JWST detects the heat emitted from active lava flows and eruption locations, charting the intense energy released as molten rock moves across the moon's surface. These findings enable scientists to comprehend how Io's intense tidal interactions with Jupiter and other moons promote its continuous volcanic activity. Even the bigger, more remote moons Ganymede and Callisto show fresh nuances. Infrared reflections indicate variations in surface composition, whereas subtle thermal emissions imply heat differences that may reveal previously unnoticed geological or atmospheric processes. For example, Ganymede's magnetic field and its subsurface ocean could affect localized warming observable in infrared, providing insights into its internal composition. Collectively, these moons create a small-scale system of worlds, each possessing its unique narrative, energy, and dynamics. JWST enables us to observe them not merely as shining dots, but as dynamic, intricate entities. The deeper our exploration, the clearer it becomes that Jupiter's moons could possess mysteries that are as significant, if not more intriguing, than the planet itself. In the shadows of the giant, these icy and volcanic worlds are alive with motion, heat, and mystery, challenging our understanding of where life-friendly conditions might exist in our solar system. Jupiter may dominate in size, but its moons may rival it in importance. What JWST found in Jupiter's atmosphere. JWST's infrared observations have opened a new window into Jupiter's complex atmosphere, revealing details invisible to previous telescopes. One of the most striking discoveries is the presence of water vapor deep in the clouds. While we knew Jupiter had water, Webb's instruments allow precise mapping of where it resides, showing concentrations in regions connected to powerful storm systems and rising convective plumes. Methane, another key molecule, is also mapped in unprecedented detail. Infrared data reveal variations in methane concentration across the planet, helping scientists understand chemical reactions occurring in different atmospheric layers and how gases circulate between belts, zones, and storms. Temperature maps derived from heat signatures further uncover the depth and intensity of turbulent jet streams, some of which extend thousands of kilometers below visible clouds, twisting and colliding in ways that drive storm formation. Beyond familiar molecules, JWST detects unusual chemical traces such as phosphine, whose abundance varies in ways that challenge current models of Jupiter's chemistry. These measurements give clues about processes deep within the atmosphere, from high-pressure reactions to upward transport of material. Understanding Jupiter's atmospheric chemistry is more than academic. These insights inform studies of exoplanets with thick, gaseous envelopes and provide context for habitability research, particularly for moons like Europa, where chemical interaction between the planet and its satellites may create environments conducive to life. JWST shows Jupiter not as a static globe, but as a living, chemically dynamic world. The deep internal structure. Beneath Jupiter's swirling clouds exists a realm nearly inconceivable, a planet lacking a solid surface, primarily made of hydrogen and helium under immense pressures. JWST's infrared studies do not directly reach the core, but they expose delicate heat patterns and atmospheric waves suggesting what exists below, strata of gas evolving into liquid and subsequently into metallic hydrogen, an unusual and exotic state of matter that acts like a metal while maintaining a fluid-like flow. Metallic hydrogen exists at pressures millions of times greater than those of Earth's atmosphere, at depths where no spacecraft could survive without being crushed long before arrival. In this layer, hydrogen carries electricity, aiding in the creation of Jupiter's enormous magnetic field. The infrared heat signatures recorded by JWST enable researchers to chart how energy flows from these deep layers to the upper atmosphere, linking the planet's internal dynamics to its storm systems and auroras above. It's a sight of both breathtaking beauty and alarming strength. Infrared images reveal radiant clouds and impressive storms. Beneath, hidden forces swirl in complete darkness, influencing the planet's climate, magnetism, and the conditions of its moons. Jupiter's grandeur is found not only in its visible features, but also in the concealed, turbulent, and enigmatic depths that render this gas giant both captivating and perilous. JWST gives us our first intimate view of a planet that is simultaneously alive, layered, and utterly alien. The mystery JWST accidentally captured. Amid all the detailed data JWST gathered on Jupiter, scientists noticed something completely unexpected: features that don't fit any known models. In infrared images, subtle heat anomalies appeared in the upper atmosphere, regions that were warmer or cooler than surrounding clouds, in ways that didn't correspond to storms or jet streams. At the same time, faint atmospheric waves, ripples of unknown origin, traced across belts and zones, moving in patterns that remain unexplained. These anomalies are small, almost ghost-like, yet significant. They suggest processes in Jupiter's atmosphere that we've never encountered before: sudden bursts of heat, localized upwellings of gas, or perhaps complex interactions between the deep interior and the upper cloud layers. Scientists are debating their origin. Could they be linked to internal heat escaping in unexpected ways? Or do they hint at chemical reactions we haven't yet modeled? The truth is, no one knows. What makes this discovery compelling is not just the phenomenon itself, but the reminder that even after centuries of studying Jupiter, a planet so familiar in images and data can still surprise us. JWST didn't set out to find a mystery, but in peeling back Jupiter's layers, it exposed questions that may take years, if not decades, to answer. Here, curiosity reigns supreme, and the universe reminds us, the more we see, the more we realize how much remains hidden. What this means for the future of planetary science. The insights gained from JWST are changing how researchers investigate gas giants, both within our solar system and in other regions. Webb offers high-resolution, global infrared images of Jupiter, enabling researchers to examine atmospheric dynamics, chemical compositions, and heat flow with unmatched detail. For the first time, we can connect surface storms, auroras, and jet streams directly to activities happening deep inside the planet, forming a comprehensive understanding of how gas giants operate. These discoveries also redefine the research of exoplanets. Numerous planets found orbiting other stars are gas giants, frequently exceeding Jupiter in size, characterized by dense atmospheres and harsh environments. The detailed mapping of Jupiter's chemistry and thermal structure by JWST offers an essential reference point. By studying our own massive planet, researchers can more effectively analyze the atmospheres, climate patterns, and possible habitability of far-off planets. Additionally, these results results are already motivating upcoming missions. Notable heat patterns, atmospheric waves, and auroral changes highlight the necessity for probes designed to investigate gas giants directly at various depths and around the planet. Concepts for next-generation orbiters, probes, and even sample return missions are being informed by what JWST has revealed, promising a new era in planetary exploration. JWST doesn't just show us Jupiter, it reshapes our understanding of planets as dynamic, layered, and chemically complex systems, guiding research for decades to come. Finally, JWST's images of Jupiter transcend mere pictures. They represent a confrontation with grandeur, strength, and amazement. In this vast world, our entire planet could reside within a single tempest, but it protects us from numerous cosmic dangers while releasing unfathomable energy. Lightning flashes are larger than entire continents, auroras shine like celestial tiaras, and under the clouds, immense pressures transform substances into otherworldly shapes. Within this grandeur exists motivation. Jupiter highlights our insignificance, yet it also reflects humanity's persistent curiosity and the urge to discover, comprehend, and wonder. Each storm, every faint heat signal, and each luminous moon narrates a tale of a vibrant, dynamic system, enlightening us not only about the giant itself, but also about planets, existence, and our position in the cosmos. JWST encourages us to move ahead, to continue questioning, continue exploring, and keep looking into the enigmas that lie beyond the clouds.